Hi guys, welcome to Coding World. So in this video we are going to discuss more about recursion. So in previous video I have started recursion and I have shown you how recursion works with the help of an Fibonacci number example. Okay, basically I have shown you how recursion works, how it uses stacks. See, there is slight difference between stack and heap data structure and the one which recursion uses. There is a very slight difference, but we will discuss about in detail in upcoming videos. Okay, now let us discuss one more very famous example and very basic example, that is known as factorial. Factorial of a number. See what I'm trying to say. Basically we are talking about recursion. Suppose I have a function called as fact of n, isn't it? Are you getting my point? See what it will do. It will give me the factorial of any number when n is greater than equal to 0. See, factorial of any number is only valid if that particular number is non-negative. See, I am saying that non-negative, I am not saying that positive. Positive means it is greater than 0, but it could be equal to 0 also. Okay, so let me write the recursive relation that this will hold. I have to return 1. Are you getting my point? I have to return 1 whenever my n becomes 0 or 1. Are you getting my point? Suppose my n becomes 0 or my n becomes 1, then I have to return 1, or else what I have to return? I have to return okay, say I have to return you can say, suppose x. Say I am telling you what is x. This x into fact of n minus 1. See, try to understand me. So let me write the proper code for this, so that you can generalize this. Suppose we have a function called as fact of n, and let's say its return type is n. Okay, and suppose if first I'll check if n is equal to you can say is equal to 0 or n is equal to 1, then you are going to do nothing. You are going to simply return n or 1. See, okay, let me return right as 1. Okay, so this is f. Otherwise what we have to do, we'll enter into the else part. What will you do in this else part? I'll make a variable x in this, isn't it? Are you getting my point? In this in this x, and what I will do, I will simply do this n into say fact of n minus 1. See, are you getting my point? See what I'm trying to say? See, okay, yeah, and after that I have to return this x value. So here I have to make a slight thing, because I have in DP concept I have told you. So basically this is the recurrence relation. Basically here should be n. Okay, x could be any intermediate, but let it generalized for n number, so it is n. Okay, so this is, I have written this in a C++ code. Suppose I am writing complete code. Okay, then you will get to know int main int n, and I will take that number, and I will just see out fact of n. Yeah, you can also make a variable, say int x equal to this, and then see out x and then indent. See, I have written a complete code in C++. Okay, you can also write in any other language. Look, now let me tell you how it is going to work. So let us start with a very basic call. Suppose I have to discuss what is the factorial of 5. See, what is the factorial of 5? The factorial of 5 is 5 into 4 into 3 into 2 into 1, isn't it? So 4 into 3, 12, 24. See, I think it is 120, isn't it? Yeah, it is 120. So I have to see that, suppose suppose in this place of n, suppose I am passing n, then definitely my x should be 120. Let us see if it is right or wrong. Suppose now let us see this recurrence relation. This is called as recurrence relation, and I have to build a recurrence tree, basically recursive tree, and I have to find out the depth of that tree also. Okay, so let us start. Suppose whenever suppose here neither n is 0. Okay, let us let us make super simple. Okay, let us forget about 0, let us talk about only n is 1. Later I will discuss about 0 case also. Okay, yeah, here also. Isn't it, guys? I have make super simple code. Okay, make super simple, only I will talk about for one case. Okay, now see, whenever my now here n is 5, see n is not 1, so it will not hit this case, it will hit this case. What it will do, it will do two things. Suppose this is this is a number, I'm numbering it, this is suppose number 1 operation and number 2 operation. So fact of 5 has to do 2 operation, first operation and second operation, but it will not hit the first operation, it will do the second operation. That means what it is going to do, it is going to do 5 into, see, for n into, it will again going to call fact of 4 for it will decrement its argument by 1, and again fact of 4 again it is going to do for two things, that is first operation, second operation. Now see, n is 4, n is not 1, so anyway it is not going to do the first operation, it is going to do the second operation. See why I am saying second operation, because n is not 1, n is greater than 1, isn't it? So what it will do, it will do 4 into fact of 3, and check fact of 3, again it will do the second operation. How it will do the second operation, it will just 3 into, it will just call fact of 2. See what I'm trying to say is, you will understand this thing in a little later. See what is fact of 2 will do, fact of 2 will do again the second operation, that means 2 into fact of 1. But see, now it hits the base case, so this is the base case. Are you getting it? This is the base case. This will return 1 to the fact of 2. And what will fact of 2 do? Now fact of 2 is in pending mode. Now it will do, basically fact of 1 is the children of fact of 2, isn't it? Are you getting my point? Now fact of 2, fact of 2's children has returned 1 to it, and it will do this 2 into the returned value, that is 1, that means 2 into 1, that is 2, and it will return to its parent, that is fact of 3, as 2. Now fact of 3, it will do the returned value into 3, that is 6, isn't it? Are you getting my point? 3 into 2, 6. Now fact of 3 will return to its parent, that is fact of 4, as 6. Are you getting my point? This is very simple. I have made the code super simple, isn't it? Are you getting my point? Now fact of 4 has got the value 6 from its children, but it will do 4 into the return value, that is 6, that is 24, and it will return to its parent, that is fact of 5, as 24. Now see, now fact of 5 already has done the first operation, second operation already has done. Now it will do 5 into 24, isn't it? 5 is in pending mode, so 5 into 24, that is 120. So fact of 5, whoever the calling fact of 5, now fact of 5 will return to it as 120. Now see, here x is calling fact of n, so x will get 120, because this fact of 5 is returning, for whom it is returning, for x it is returning as 120. Now it will print 120, which is the correct output, isn't it? Are you getting my point? See, again this is the recurrence tree, this is the recursive tree. See, here it is 2 power 0. You can see that all are 2 power 0. See, all are 2 power 0, but this is not 2 power 0. Okay, this is not 2 power 0. See why I am saying that. See, in this it is 2 power 0, but in this that is 2 power 0 and another 5 into it is pending in. Okay, so anyway it is, you can say it is of big O of n, isn't it? If I consider only this much. Okay, so this is the big O of n space. Are you getting my point? So this is constant number, so this will not, this will not contribute too much space, but this will going to be contributed in the space. Okay, anyway this is going to be consume constant space, but this will take some space, and that is big O of n. For n as big as, suppose if my n is 10 raised to the power 18, then definitely it is going to take, big O of 10 raised to the power 18 space, which is, exponential, which is taking much more space. But anyway, okay, we will also see some advanced algorithms that will, optimize this space, but we will see this in a later part of this video. Okay.